Okay, guys, so today we are going to talk about factoring by grouping. All right, hopefully, you guys have a pretty easy time with this because this isn't too bad. But later this week, we're going to kind of tie in some things together with the stuff we've learned already with leading coefficients and factoring out of GCF and using factors to help us to factor. And then we're going to tie in this last concept, grouping. So this is kind of the last piece of the puzzle before we get to the grand finale, for lack of a better way of saying it. Okay, so um, factoring by grouping is really exactly how it sounds, guys. You're going to make groups. Okay, so in this first problem here, number 9, you're going to make a group out of the first two terms of this polynomial, and you're going to make a group out of the second two terms. So you're going to separate these in two different groups, and you're going to factor out a GCF separately in each group. So in that first group, the first thing you should recognize is that these are each divisible by 7. Those are two numbers that are evenly divisible by 7. And they also both have ends. Okay, we talked about taking out variables. You always take out the smaller variable because you can only take out what they both have. So I'm going to take away an n squared from each of those two terms. So a 7n squared is what goes on the outside. All right, and then I go term by term on the inside, and I see what happens after I took that away. So 35 divided by 7, that will leave me with 5. I started with 3 n's. I took away 2 of them, so you're left with an n. Plus 28 divided by 7 is 4. The n squareds here actually cancel each other out, so you have no n's left. So I got a 5n plus 4 on the inside there. Then I go on to the second group. Okay, in the second group, the first thing you should notice in this problem is these two numbers are both all evenly divisible by 5. Okay, so that's going to come out. This term right here has an n, but this term does not. So you can't take away an n. You can't. So we're going to leave that part alone. 25 divided by 5 is 5. The n's got to stay. Plus 20 divided by 5 is 4. Now, what you should notice is that the binomials on the inside of each of those groups are exactly the same. That is exactly what should happen. If that does not happen, guys, in all likelihood, you did something wrong. So you got to go back and check. Okay. Once you do that part, guys, you're home free. Okay. Whatever the binomial is that repeats, in this case, the 5n plus 4, that's going to make up one group of your final answer. And then the two things that got taken out, the 7n squared plus 5, that's going to make up the other group. Okay, now again, remember you can write this in reverse. You can write this like this. Okay, in a multiple choice scenario, guys, or a matching scenario, this would probably be how they write the answer. All right, so just be heads up for that. Okay, all right, in the second one, something a little different happens here, which is why I showed it to you, but most of it's the same. Okay, I got my groups, right? Okay, these two numbers, a 21 and a 56, they are both evenly divisible by 7. I am also going to take out an n squared since that is the smaller exponent. Okay, very similar to number 1, as you can see. Okay, so a 7n squared is what goes on the outside. All right, 21 divided by 7 gives me a 3. Started with 3 n's, took away 2 of them, you're going to be left with 1. Plus 56 divided by 7 is 8. The n squareds cancel out. Okay, now something a little tricky happens here because we had a minus in the middle. So I'm going to leave the middle empty for right now. All right, so watch what happens. When you take away a 3, which is the number you're going to take away there because those are two numbers that are evenly divisible by 3, and I put a 3 on the outside, watch what happens here. -9, that's a -9. -9 divided by 3 is -3. The n's got to stay. -24 divided by 3 is -8. Okay, so the problem is that on this side we have 3n plus 8. On this side I have -3n minus 8. Very, very close to being the same, but they're not. Okay, so what you have to do when you have a minus sign in there, okay, to make these, really, we want this to be 3n plus 8. We want this 3n to be a positive, and we want this 8 to be a positive. So we want them to be the opposite of what they are. So what I'm going to do, guys, is I'm going to factor out a negative sign. So a negative is going to come out. That 3n now becomes positive. This 8 now becomes positive. So you're allowed to do that to change the signs. It's kind of just like distributing a negative. When you distribute a negative sign, it changes the signs of everything on the inside of the parentheses. It works the exact same if you do the reverse. If you take away a negative, that's also going to make it the opposite. Okay, so now we got our groups matching, right? We got our 3n plus 8. Okay, so 3n plus 8 is what makes up one of the groups. And then you got your 7n squared and your minus 3 making up the other group. 7n squared minus 3. Okay, you could flip that around, but in a multiple choice or a matching scenario, guys, in all likelihood anyway, don't quote me on it, but you're going to see it like that. So that is our final answer for that problem, number 10. Okay, so guys, it's pretty straightforward. Just be heads up for that negative that's kind of shoved in the middle there. Every once in a while that throws a wrinkle, so be careful. And guys, like always, if you're having trouble, if you have questions, please, okay, reach out. I'm more than willing to help.